Let's take a look at examples of solving equations. So here we have y, and then y plus 4, and then 10y minus 7 equals 0. So you apply the principle of zero products. That says you take each factor. The y is a factor, the y plus 4 is a factor, 10y minus 7 is a factor, and you set each factor equal to 0 because on the right side, notice you have a 0. So I have y equal to 0. You just set that factor to equal to 0. In this case, there's nothing to be done. So y equals 0 is just one solution, that's all. If you plug it back into the original, you will see that 0 times whatever is 0. That solves the original equation. Let's do the next one here. I'm going to have now y plus 4 equals 0. So when you solve this, y equals negative 4. From here to here, I just subtract 4 from both sides. So y equals negative 4 is another solution. If you plug it back into the original, you will see negative 4 plus 4 is 0. 0 times the other values there would still be 0. And then the last one will be like this. So you take your 10y minus 7 set equal to 0. You add 7 to both sides, so 10y equals 7. From here to here I did plus 7. And then you divide both sides by 10. So I guess y equals here 7/10. So from here to here, divide both sides by 10. So 7/10 is the third solution. So there are 3 of them. 0 is 1. Negative 4 is 1, and now 7/10 was another one. Let's do another one. This one is a little more complex, but it follows the same logic. You simply set each factor equal to 0. So x minus 4 equals 0. That tells you that x equals positive 4. From here to here you add 4. And then you take x minus 2 equal to 0. So x equals positive 2. So from here to here you add 2. So that's another solution, just like 4 is a solution. Last factor, you set that equal to 0, so that's going to look like this. Let's see, 11x minus 14 equals to 0. So first, 11x equals positive 14. From here to here, you add 14. And then you divide by 11, so x equals 14/11. So from here to here, you divide both sides by 11. And so this is a solution. So all the solutions are 4, 2, 14/11. The next one says solve by factor and give all the real solutions. Again, here it's a little bit different because the left side is not already in a factored form. You have to bring it into a factored form. So you can set each factor equal to 0. So for that reason, you first need to factor common factors out. Usually begin with a GCF. So I'm going to say negative 3 times x times x times x. First I'm just writing the x cubed as 3 x's multiplied together. That's what it means. I'm going to rewrite that 12, for example, this way. I'm going to say here 4 times 3 times x equals 0. And I've done it this way because I see that now both terms, those are the things before and after the plus sign, those are the terms, both have a 3 that I can factor out. Negative 3 in fact. And then also an x. So I can factor this out, say this x out, and this negative 3 out. So when I do that, negative 3x goes out, and within the parentheses, make sure you copy the 0 straight down. Within the parentheses, you stay with these other 2 x's from the first term, which is just, again, x squared. And the other part there would be negative 4. And it's important to understand, when you factor that negative 3 out from each term, I don't want to go into too much detail so it's not overwhelming, but just remember to change the sign, that's all. So from the first time when I factor negative 3 out, notice that in the second term, there does not appear to be a negative 3. That's okay. You factor it, and then you just change the sign from positive 4 to negative 4. And I know that works because if I redistribute the negative 3 over the parentheses, it would restore the original plus sign. Okay? So from here to here, I basically took negative 3x like that, okay? Went out. And in the second term especially, which was positive 4 became, let me make this note here, negative 4. And then you apply the principle of difference of squares. X squared minus 4 is a difference of squares. So it's going to look like this, negative 3x. So this is going to factor into x minus 2 and then x plus 2. That's a basic difference of squares. So from here to here, remember this pattern. A squared minus b squared is equal to a minus b times a plus b. So you factor, and then at the next stage, I'm going to have negative 3x. You're going to set that equal to 0. Negative 3x is one of the factors, so you're going to set that equal to 0, okay? Like that. You take negative 3x, set equal to 0. You take x minus 2, set equal to 0. And you take x plus 2, and you set that equal to 0. Now, from negative 3x equals 0, you divide both sides by negative 3. That's going to tell you x equals 0 is one value. From the second where it says x minus 2 equals to 0, you add 2. So x equals positive 2 is another value. And then x plus 2 equals 0 means you subtract 2, so you're going to end up with x equals negative 2. Like that. So all of the solutions can now be made as a list. 0 is a solution, positive 2 is a solution, and then negative 2 is another solution. These are the solutions. Let's do one last example here. Again, it's going to look like this. I have negative 2x cubed minus 2x squared plus 12x equals 0. You want to factor a negative 2 from each term here. For factoring, you always want, as much as possible, to have a positive coefficient on the leading term. X cubed is the leading term. So I'm going to say negative 2. And I'm going to say here times x times x times x minus 2 times x plus 2 times 6 times x equals 0. That 12 can be re-expressed as 2 times 6. And then from here, anything that is common you can try to pull out. So for example, let's say I'm going to go with negative 2, and then here the 2. Remember in the last term where it says plus 2 times 6 times x, when you pull the negative 2 out, just make sure to remember to change the sign. And then let's see, this x is common, this x is common, and this x is common. So you pull all of that out. Negative 2x goes out. What remains within the parentheses are the things that remain there. So let's see. From the first term, it's x times x, which is x squared. From the next term, what remains is basically positive x, like that. Because I took the negative with the 2 out, so positive 1x remains. And in the last term now, be careful because I know it appears like a positive 2, but when you pull it out, just remember on the inside here, change the sign. So it becomes positive and then 6. The positive 2 and the x go out. When you do that, change the sign. So again, from here to here, negative 2x. Okay? Out. And then at this point, you can factor the trinomial. So let's do that next. From here to here, factor. So I'm going to have the following to factor. I need the same two numbers that multiply to negative 6 and the same two numbers that add to positive 1. Let's take a look. So I have negative 3 and negative 2. Well, these don't work because negative 3 times negative 2 is positive 6. So these are not the good values. So maybe make the 3 positive and make the 2 negative. Let's see. Negative 3 times negative 2 is negative 6. That checks. And let's see. Positive 3 plus negative 2 is positive 1. That also checks. Remember, that positive 1 is this value right here, okay? And all of this is still set equal to 0. So now you rewrite this. It becomes x plus 3, and then becomes x minus 2 equals 0 still the entire time. All right, now lastly, you apply the principle of zero products. So either negative 2x is 0, or x plus 3 is 0, or x minus 2 is 0. Let's solve this. Negative 2x equals 0 means you divide both sides by negative 2. So x equals 0 is one quantity. You take x plus 3 equal to 0 and you solve that. So x equals negative 3 is another quantity. That's another solution. Then x minus 2 equals 0 means x equals positive 2 is another solution right here, okay? X equals positive 2. So the solutions are 0, negative 3, and positive 2. And that's it.